In this video, we're going to learn LangGraph from beginner to advanced. We are going to get 80% of practice and 20% of theories. We are going to learn what is LangGraph and how it works. We're going to talk about some use cases of LangGraph, and we're going to learn what is node and what is an edge. On chapter 2, you're going to learn how to build a first graph. You're going to learn what is node and what is an edge. On chapter 3, you're going to learn how to build a Q&A over workflow using LangGraph. On chapter 4, we are going to build a corrective RAG pipeline. You're going to learn what is corrective RAG and how it works in practice. On chapter 5, we're going to talk about self-RAG. You're going to learn how to build a system that evaluates a turn response. On chapter 6, you're going to learn how to build and design an adaptive RAG pipeline. On chapter 7, we're going to talk about reflection. We're going to learn how to build a system that reflects on its own answer. We're going to talk about basic reflection, and we're going to talk about reflection. On chapter 8, you're going to learn how to build a multi-agent system using Handoff Pattern. In here, you're going to learn what is Handoff Pattern and how to use it in order to build efficient multi-agent system. On chapter 9, I'm going to invite you to go check out my video, Manage a Clone, in order to pull your skill to test. Let's get started. Alright guys, now let's talk about LangGraph. LangGraph is a framework that allows you to build stateful agents using graph-based logic. Now, here you can see we have the words graph-based logic. It means our agents are going to be composed with a set of nodes and edges. And also we have here stateful agents. It means an agent equipped with memory is an agent that can remember previous interaction. With LangGraph, you have the possibility to build this kind of agents that can remember everything for you. Now, let's talk about some use cases in here. We can use it in order to build autonomous agents. We can use it in workflow automation. We can use it to build a multi-agent system. Now, to understand how LangGraph works better, we're going to take a look to this little graph right here. Now, you can see this graph here is composed with a set of nodes and edges. You can see A is a node, B is a node here, and C is a node. These nodes are basically agents, or it can be a function. Now, from this node here, we can move to another node here. Now, in order to move here from node A, we are going to use here an edge. We have here normal edge and conditional edge. Now, let's say the user crafts an input. We are going to forward it to the node A. And then from the node A, we are going to transition that input to a conditional edge here. Now, from this conditional edge here, we can decide if it's better to move the user input to the node B or node C. You can think of a conditional edge as a classifier. A classifier. It's going to classify the user inputs. Let's say here, you can see we have something like this. You can see in here we have a finance agent here. And here we have the health agents. Okay. Now, let's say the user input is about how to take a next medicine. Now, we are going to move this input to the supervised agent. The supervised agent here is the classifier. Now, the classifier here is going to decide here if it's better to move the user input to the finance agents or to the health agents. And that's how a LangGraph workflow basically works, guys. You can see it is composed with a set of nodes and edges. Okay, it's composed with a set of nodes and edges. Now you can see in here we have here the node A. This is node A here. We pass here the user inputs, and then from the node A, we can use here an edge in order to move the user input to a conditional edge here. And once we move the user to a conditional edge, we are going to decide if it's better to move the user input to the node B or C. Okay, the conditional edge here you can think of a classifier. This is a classifier. It classifies the user input. That's how it works. Now, before we get into the practice, I'm going to show you something. We are going to see here why we should use LangGraph over LangChain. Okay, we're gonna see the difference. Okay, and guys, if you don't know LangChain, go check it out, my LangChain course. And LangChain here is a prerequisite. Okay, you must know LangChain. Okay, now let's see here difference between a multi-agent system built with LangGraph and a multi-agent system built with LangChain. Now, here you're gonna see we are with LangGraph, we have the possibility to build a multi-agent system that offers more flexibility. Now, when I'm talking about more flexibility, it means the user can interact with sub-agents. Whereas with this system that we built here with LangChain, the user doesn't have the possibility to interact with sub-agents. Now, let's see how it works. Now, you can see here we have the user. Let me zoom a little bit. We have the user right here. The user forwards his inputs about buying coffee to the main agent here, which is the coordinator. Now, the coordinator here, the main agent, has here is one sub-agent, coffee agents. And the coffee agent here has a tool that allows you to buy coffee. Now, here, the main agent is going to receive here the user input. And then it's going to invoke here the sub-agents, coffee agents. It's going to pass here that input. Okay. And then the coffee agents, it's going to call here a tool that allows you to buy coffee. Call tool. Okay. It's going to call here the tool. Now, once he call the tool is going to respond here. It's going to return here response. Okay. And then here you can see this agent here, it's going to have here the response. Now, once it is here the response, instead of passing here this response to the main agent, it's going to pass you the response immediately to the user. Okay. You can see with this system, we have the possibility to communicate directly with the user. A sub-agent can communicate directly with the user. Okay, guys, you can see this is what I call flexibility. With this kind of system, the user can interact with sub-agents. Now, let's see here this system right here. With this system, the user have only the possibility to interact only with the main agents. Now, let's see how it works. Now, you can see we have here the user. Now, the user crafts an input buying coffee. We're going to forward it to the manager agent here. Now, the manager agent here has a sub-agent. Let me do something like this. It can look like this. Let me be simple here. Let me get rid of this. And I'm going to pass here another system that looks like this. Okay, we are going to take here system. Let me check here system. Okay, yeah, I'm gonna pick here system. I got a system here. I'm pass it here. Okay, and then we're gonna see it works. Now you can see this is a system here built with LangChain. Here, once the user crafts the input, it's gonna pass it to the manage agents. Now the manage agent here has sub-agents. It has this sub-agent here, and it has this, and it has this here. Now here, the manage agent can order this agent here to do a task. Okay, it can, let's say it can fetch data in the vector database. And then once it has data, it's not going to pass it immediately to the user. We have here the user. It's not going to pass it immediately to the user, but instead, it's going to pass the data to the manager agents. And then the manager agent is going to respond to the user. That's how it works. If you're building a multi-agent system with LangChain, this is how it works. But if you're building a multi-agent system with LangGraph, the system can look like this. We have here the manager agents, and it has here sub-agents. Okay. And here, once these sub-agents here respond, it's gonna give here the user the feedback. Okay, we have here the user. It's gonna give here the user the feedback. Okay, this is how it works. With LangGraph, we can build a multi-agent system that offers a more control and flexibility. You're gonna understand that pretty well when we're gonna get into the practice. Right now, it may seem complicated to you, but soon you're gonna understand it how it works. You're gonna see that with LangGraph, we can build a robust multi-agent system. Now, let's move to the second chapter where we're gonna learn how to build our first graph. Okay. Alright guys, now we're going to learn how to build our first graph in LangGraph. Now, the first thing we need to do, we have to head on langchain.com. And once you head on langchain.com, you're going to get into the installation menu. Now you're going to tap here this command in order to install LangChain. After that, you're going to click here LangGraph. Head into, again, here install menu, head into in here. Now you're going to tap here this command in order to install LangGraph. And there we go. You just finished, guys. You're ready. And if you got installation errors, guys, in your Node.js projects, try to pass here .npm rc, try to pass here file, and then pass here legacy pdefs is equal to true. If you got installation errors, try to pass this file there. Okay. And if you don't know how, if you don't want to do all of this, you can head on the GitHub repository and clone this repository, and then tap npm install in order to set up everything. Okay. Now we're going to learn how to create our first graph. Now what I'm going to do, we're gonna head into the chapter 1 example 01.js, and in here, in order to create our first graph, we're gonna import here the end node. We're gonna import here the starting node. We're gonna import the state graph. We're gonna import the annotation graph from LangGraph. Okay, that's all we need to do, guys. Now we're going to pass here this. We're gonna pass here annotation.root, and then you can see pass here an object, and then I pass here aggregate. Aggregate right here is a state. I'm gonna get into that later. Okay, this is how we create a state in LangGraph. You know, if you're working with Redux, you want to start creating a slice, you have to define states. Now in LangGraph, in order to define state here, we use annotation.root function. Now you can see here we define a state aggregate, and it is here default value is equal to an array. This is an array. Aggregate is an array. We're gonna get into that later, guys. Okay. Now this is how we create a state. Now, once we create a state, we're going to pass here a node. A node is basically a function, as I said previously. You can see node A, and then it takes here the state as parameter. And as we pass the state as parameter to that function, we're going to have the possibility to get access to all of our states, okay, via the state parameter. Now, I'm going to pass here builder. This is a variable, is equal to new state, and then pass here state annotation, okay. This is the graph. And here pass here the node, add node A. I pass here now this function, okay? And then I pass here an edge. Okay, let me show you how this looks like. I'm gonna head on right here. You're gonna see it looks like this. Let me remove right here this to node right here. I'm gonna get rid of this. I'm gonna get rid of this line right here. It looks like this. Okay, guys, you can see right here we have the starting node. And then we have here the node A. Now from the node A, we have an edge here. This is an edge. Let me show you, we got an edge here. Okay, now from the node A, we are going to transition to the end node. Okay, now let's see here. You can see we have here add node, I pass here A, node A. And then I pass here an edge. From the starting node here, from I pass here add edge, I pass here the starting node. And then I pass here we are going to transition from the starting node to node B to node A, and then here pass another edge here from node A to the end node. It means you can see it looks like this. We're gonna start here with the starting node. Okay, now from the starting node we have here an edge. Okay, this edge right here. Now we are going to use here this edge to move from the starting node to node A. Now from the node A, we're going to transition from the end node. Now you can see in here, we have here from the edge here, from the node A, we are going to transition to the end node. And then here we compile the graph. And then we invoke the graph right here. We pass here graph that invoke, and I pass here the state, aggregate, and I pass the default value is equal to an empty array. Then I console here the graph, base result, okay? Like this. Now let's see how it looks like if we run this. If I run this, you're gonna see from node A, you can see actually we console here this node right here, console from node A, and you can see inside the aggregate state here we have here an object, we have here I am A. Now as I return here this node, we are going to add in data. Okay, I'm not commenting this right now. And then let's try to run this again and see what we got here. We aren't gonna push anything inside the aggregate. Aggregate is a state, as I said before, and you can see pass here from node A. Okay. Now let me pass here another state. I can copy this, and then I can pass here another state. I can say users, something like this, and then pass here annotation. And here we pass here, you can see we have here an object, and instead of it we have the reducer function. The reducer function, it allows to modify here the state. Now you can see pass here x is the previous value and y is the next value. Now once we push here a value into the users array, we are going to the previous value here is x. Previous value is an empty array. So as previous value is an empty array, and then the next value, let's say the next value is, let's say something like this is Ben. We are going to take here, x is an empty array, that's concat. We're going to push Ben into the array. It looks like this. Let me show you right here. If I head into node here, and I define here an empty array, const x is equal to an empty array like this. X is equal to an empty array. If I pass here that concat, we are going to, concat, and pass here concat like this. We're gonna push in something and pass it Ben, okay, like this. You can see that actually we push Ben into the array. This how it works. Here, guys, reduce a function, it allows to modify the state, only that. And here the default function, it allows to define the initial value of the array. Now, if I pass here something like this, and pass the initial item, okay? Now, when we're gonna run this, let's say we move here, and then I pass the users, I return here users, I push in something. This is gonna be the next value, okay? The initial value is x here. The next value is gonna be y here. If I pass here Chris, now if I run this, you're gonna see we're gonna have here we're gonna have data. Let me do something like this, and I'm gonna run this, okay, like this. Yeah, you can see actually right here we have two states. We have here aggregate, the actual value is an empty array, and we have here users. This is an array too, and you can see this is the initial item, and then we add here another item. Now you can see, guys, when we run this, we are moving from the starting node, then we move here to the node A, and then we hit here the end node. Okay, this how it works. Okay, you can see pretty simple. From the node A, first of all, when you're building graph, you have to pass here nodes. Okay, let's say I pass in a node, like I pass here node B. Okay, and then I'm pass here IMB from node B, and then from node B I'm pass here bin, okay, something like this, bin, and then here I'm going to pass here, I'm gonna register first this node, I'm pass it here, the name is B, node B, like this. Once you register a node, now it comes to create a road. Okay, this road, it allows a node to move from one point to another. Now you can see we're gonna start with the starting node from node A. Then here we are going to move here from node A to B. Okay, like this. I modify from B to end. Okay, like this. We just modify this, guys. It looks like this right now. You can see this is the starting node. From starting node, we're gonna move here to A. These are edges. From A, we're gonna move here to B. And from B, we're gonna move here to end. Okay, this is how it works. Now you can see in here we have from starting node to A, from A to B, from B to end. Now let's try to run this and see what it looks like. Okay, I'm gonna run this. Yeah, you can see it works. You can see, first of all, we start from the starting node. From the starting node, we don't have anything from the starting node to node A, and then from node A to B. Now you can see in here pass initial item, then pass here Chris and bin. Okay, you can see in here when I pass here return, I return an object, then I pass here the name of the state. We are modifying the state, guys. Okay, yeah, you can see the initial value right here is initial item, and also you can pass here the initial value. You can pass even here too, users. And then if I pass here empty, I'm going to override this. I'm not override this value right here. You can see, let's run this. You're gonna see we're gonna override that. Yeah, we don't override it. Okay, yeah, we got here initial array. Okay, let me try to pass here something. And pass here Albert, something like this. If I run this, okay. Let's see, yeah, we got here, right now we got here Albert. Okay, we added to Albert. Yeah, this how it works. Now, guys, you can see this is a simple graph that we just created. It's pretty simple, guys, okay? In here, we don't have a conditional edge, okay? The first graph that we just created looks like this. Now we're gonna learn how to create this one here. For this one here, we have a conditional age. Okay, right here we have a conditional age here. Now we're gonna learn how to create this too. Okay, now guys, try to hit pause and practice. Try to practice a little bit. Okay, try to practice a little bit and try to understand things. Okay, this is how we create a simple graph. Okay, try to practice. Now we're gonna learn how to create a graph with a conditional age. Okay, you can see we have node A here, and here we have a conditional age. Now from here, we're gonna decide if we can move to B or C, and then we're gonna add here the end nodes. Okay, now I'm going to head into in here. First of all, I'm gonna copy this node B. I'm gonna convert it into C. Okay, something like this. Now here I'm pass here from node C, and then I'm pass here data from node C. Okay, like this. We're gonna update the user state. Okay, let me copy this, and we're gonna get into the chapter 1 exercise 2. Here I'm going to pass it at the bottom here. Okay, now I'm going to take here the node, and then what I'm going to do, I'm going to add it to the graph. I'm pass C, and then I'm pass here like this. Now the next thing we're gonna do here, we need to create here a router. I'm gonna copy this. Okay, you can see we have here A, B, C. Okay, let me check here. A, B, C. Okay, now we need to create a router. I'm gonna copy this, and then I'm pass here router. I'm pass here router node. Yeah, router node like this. Now what we're gonna do here, guys, I'm going to take the router, and then I'm going to pass it in here. You can see from node A we have here conditional age. Now I'm gonna add here conditional age, pass here add conditional age, and then I'm pass here A, the name of the node here, and then I'm pass here router node like this. Okay, we add here a conditional age. Now what we're gonna do next, guys, I'm going to pass here condition. I'm going to check here something like that, pass here if users that length, the user's array. Yeah, in order to get access to the state, we need to pass here state that users array that's length, and pass that length like this. The value is greater than 0. We are going to do something like this, and pass here return, and pass here return. We're gonna pass here an array, and pass here we're gonna move. Let's say if the user's array is greater than 0, we're gonna move here, let's say to node C. Else we're gonna move here to node B. Yeah, let me check here again. Yeah, we're gonna move to node C or B. We're gonna move here to node B here like this, and then I'm gonna remove this. Okay, now what I'm going to do next, I'm going to run this. Now you can see here pass here an age from the starting node to, we are going to move here to a conditional age. Now from a conditional age here, you can see we can transition from B to end and from C to end. You can see. Now what I'm going to do, I'm going to do something like this. I'm take here this from passive from B, okay, from B to end here. I'm passive end, and I'm passive from C to end. I'm passive C. Okay, like this. And now we're gonna run this and see what we're gonna get here. From A to a conditional age here. Now from conditional age, we're gonna transition to B, and from B to end. Okay, something like this. Now let's run this, and I'm passing node. We're gonna pass here chapter. I'm passing chapter. Yeah, we're gonna move past the chapter exercise 2, and then we're gonna see what we're gonna get here. Yeah, you can see here, guys, we just pass here from node A to C. Okay, from node A to C. We don't pass here from B. Okay, we don't move to the node B. You can see in here, guys, we have a condition here. If the user's array is greater than 0, we're gonna move here to C, but we aren't gonna move here to B. Okay, that's why you can see we don't console here from node A, from node B. Yeah, we don't have here from node B. Okay, and you can see inside this array pass the data from node C. Okay, we move. It means we move from node C. And here, let me do something like this. Let me pass here the inverse. I'm passing from B, and then I'm passing from C. If the user's array is greater than 0, we're gonna pass here C, like this. Okay, we're gonna pass here C. Now, if you run this again, you're gonna see we aren't gonna render here. We aren't gonna run here C. Okay, yeah. Now you can see here we have here something like, yeah. Now you can see, guys, we have here from node A to, now you can see here, guys, we have from node A, from node B. Yeah, we don't move here to the node C here. You can see with a conditional node, we can decide on which node we can move to, okay, based on the condition. Okay, you can see we have a little condition, and then we return here the name of the node that we want to move to. Okay, you can see that's how it works, guys. Okay, we have a conditional age. Okay, now try to practice, guys. Try to practice. Okay, in order to understand, try to practice. Try to create a mini exercise, and then try to implement it. Okay, this how it works. Okay, now we're gonna move to the next chapter. We're gonna learn how to create a Q&A over documents workflow using LangGraph in order to put everything we've learned so far in practice. I see you there. Alright, guys, now we're gonna learn how to build a Q&A over document workflow using LangGraph. So before we get going, guys, I want you to know that throughout this chapter, I need you to have the basic of RAG. You need to know what is RAG and know how to implement a naive RAG pipeline using LangChain. Okay, you need to have the basic here. If you don't know what is RAG, you aren't going to understand it pretty well. Now, right here you can see we have here our workflow. Here's our workflow, guys. You can see it is composed with a set of nodes and edges. Now you can see we have here the user input. Now we're going to take here the user input. We're going to forward it to a query analysis node right here. Now the query analysis node here, guys, is basically an LLM. We are going to take it and then we're going to analyze it. We're going to check if the user input is related to the data that we got within the vector database. If it's related to the data that we got within the vector database, we are going to return here yes. Okay, if the LLM return here no, we are going to forward the user to a node here out of scope, and then the user is gonna hit here the end node. If it's yes here, we're gonna forward the user to the query run node where they're gonna take the user input and then they're gonna create multiple versions of the user inputs. If the user say, for example, hello, yeah, for example, what is prompt engineering, they're gonna take that input and then they're gonna convert it into multiple versions of that input for better retrieval. Now, after that, they're going to take here the user to a conditional age here. We're going to route here the user to the retrieving node here, because here the query write node, it's going to return here the retrieval node. And once we detect here that the current node here is the retriever node, we're going to move here the user to the retriever node in order to retrieve data in a vector database based on this question generated by the LLM. Now, once we run the retriever node here, we are going to take now these documents right here. We're going to take here these retrieved documents. We're going to pass it to another node here, generate node. We are going to use here this node in order to generate the response to the user. Okay, we are going to take this and then we're going to give the user the response. It's going to look like this. You can see we have here the user going to respond to the user. Okay, now this is how it works. Now we're going to get into the code and see how it works in practice. Okay, this is the theory, guys. This is the theory. You understand the theory. It's pretty easy. Now let's see how it works in action. Now in here, guys, I'm gonna show something. You can see in here, guys, let me zoom a little bit. You can see in here, guys, we have here a chapter. This is a chapter 2. On chapter 2 we get the basic. You can see we have here basics, 3 examples. Okay, you can see this is what we learn on chapter 2. Now on chapter 3 we have the real world example. Okay, now you can see in here I have the prompt TS file. Okay, in here we have a system prompt. Now you can see we have here system prompts that I use to generate multiple versions of the user inputs, and I pass here, yeah, I'm not getting to that later. We have here system prompts that I use in order to generate the response, and this system prompt I use it on this node right here, on the generate node. We have here system prompts here. We have here system prompt. I use the system prompt on the query analysis node. And we have here system prompt for categorization of the user inputs. We use the system prompt on the query analysis node too. Okay, In the prompt.ts file, we have only system prompts, nothing else. Now you can see here we have a basic embedding pipeline. Okay, we take here these docs here. This one talks about prompt engineering, and this one talks about how LLM powered autonomous agents. I'm gonna take here these two docs, and then I'm gonna embed it into the vector database. As a document loader here, I'm using Cheerio in order to extract data from this URL, and then I'm gonna get here an array of documents. I'm gonna flat it, and then I'm take it. I'm gonna split it into multiple chunks using recursive character splitter. You can see the chunk size 1000, chunk overlap 200, and then I'm going to take here these documents. I'm going to pass it to a vector database. That's how it works. So you know how to implement an embedding pipeline. I consider you know how to do that. And we have here a basic retrieving pipeline. This is a basic retrieving pipeline. We have here the user input, and then we use here query embeddings in order to convert the user inputs into embeddings so that we can perform similarity search in the vector database. Okay, and once we get data from the vector database, we're gonna return here top 5 doc. Okay, now we're gonna get into the chapter free.js, and what I'm going to do in here, guys, I'm going to import here some page that we're gonna use in order to build our graph. Now you can see we import here the end node. This here is basically a constant, guys. You can see we have here end, and we have here the start. This is a constant, okay? And now you can see pass your state graph. We use here this one in order to initialize our graph, and we have here annotation in order to create states. You can see when we pass here annotation, that's root, and then we can pass here states. Okay, we learned how to do that previously. And in order to update the states, we are going to head into the node here, and then we can pass here the name of the state that we want to update, and now I can pass here some value. You can see we have here the state here, guys, and then we have here my node, and then I pass here current output, and then I pass here some new value, and then we pass it in here, and then we're gonna build our graph. We learned how to do that previously. Now, in here, guys, you can see I import here some message, a message, human message, system message from LangChain, and I import here our prompts. Now we import here to the retriever, and I pass here chassis breast as model provider. That's what I'm not using. That's what I'm going to use here. If you don't have the key, head on chassis breast. Okay, head on chassis breast, and then you're gonna copy your API keys. Totally free, guys. If I head into API keys, yeah, you're gonna generate an API key, and then you're gonna copy it. And then if you wanna copy the model, I'm gonna go here, get started, and you can see at the bottom here, you can use this, you can use this, you can select even this. Okay, now I pick here this one right here, GPT. I pick this one here, GPT says it is a 120 billion parameter. Don't choose this one, it's not pretty smart, guys. Okay, now let's go on. Now here you can see I pass here the model, and then here I'm gonna pass here the graph. And you can see we pass here the message annotation.spec. So the message annotation is basically the state right here. Okay, I can say the message annotation.spec is basically a shortcut. If I copy this and I pass it in here, we have the same thing. It's basically the same thing, okay? It's basically a state. And you can see the state here is a pre-built-in state annotations, okay, that combines return messages. Now, inside the message array, you're going to put in the conversation between the A and the human. We have here another set here, rewrite queries. You know, guys, if we head into in here, you can see here once we take the user input here, we move it to the query route node. We are going to take the user input, and then we're going to generate multiple versions of it. Now we're going to take here these generated queries. We're gonna put it inside the rewrite queries array. Okay, we're going to put it in here. Okay, so that we can get access to it into another node. Okay, we can get access to it into the retriever node or into the generator node. Now I'm going to move here. You can see we have here another state, next node. This is basically string. Now here, if the next node here, let's say the classifier here said the next node is equal to query run node, we are going to move to the query run node. Okay, if the query classifier said the next node is out of scope, okay, let's say the user pass an input which is not related to the document that we got within our vector database, we're gonna get out of scope. You can see we have here prompt, a categorization system prompt. You can see we have here something like this. Yeah, you can see here, let me start here. UI writing classifier inside a structured LangGraph workflow. Okay, now here your only task is to decide whether the user's question should be routed to the retriever node or marked as out of scope. Now, if here the query analysis node marked the user input as out of scope, we're gonna route it immediately to this node here, and then we're gonna add the end node. Okay. Now here, once the LLM return here, let's say next node is equal to query write, we are going to take that and then we're gonna store it inside the next node states. Now, once we retrieved here data, we're going to take the data, we're gonna push it inside this array, retrieve document. Now you can see we have here retriever nodes. When we move from the query write nodes, we are going to use here these queries in order to retrieve data in the vector database, and then we're going to push all these retrieved documents into the retrieved document array. Now we're going to create here our first node. Okay, our first node here is the query analysis node. Okay, I named the function here initial node, and you can see message history states that message. This returns here an array of message. Okay, previously I said in order to get access to the state, we pass here state is parameter, and then we can get access to all these states in here. And then here I'm passing state that message. Now I use here structured output. If you don't know what is a structured output, I invite you to go check it out my LangChain course. Now here I pass here model with structured output, and then I pass here next node. It should be it should be here retriever node or out of scope. Okay, here we should pass here retriever. Let me check here. We have an error here. Okay, it should be here query run node. Okay, I'm going to modify that. I'm going to head into in here. I'm not heading to inside the system prompts here, and then we're gonna modify that. It's gonna be here query write. Okay, not retriever. Okay, here I should pass here. Let me check here for the retriever and I look for it. Yeah, we got here the retriever. Okay, yeah, this. Okay, we are going to route to the query write node or out of scope. Okay, now I'm going to take that and then I'm going to pass it in here. Okay, we're gonna pass in here, and then here once the LLM returns the response, I'm gonna pass here next node, and I'll pass the result that next node. Okay, we're gonna modify here the states. You can see we have here the states. We're gonna modify the states. Now, once we modify the state, we're gonna move here to another node here, query write node. Okay, we're going to take here the mess array, and then I'm going to I'm not check here the type of the message. Okay, you can see pass the state the message that filter, and then I check here the message type is equal to human, and then we are going to extract it. Okay. Okay, if the message type is equal to human, we're going to extract it. And then here again, I'm going to take here now the user input. I pass in here. I take the user input, I pass it here. And then I'm going to tell the LLM to generate multiple versions of the user input. And you can see a system prompts that we pass here. We pass here query rewrite prompts. Okay, if I click here and we read a little bit, you are the multi-query agent specialized in generating high-quality research queries for semantic search. And then you can see your job is to generate multiple search queries based on the user's original question. The queries should optimize the recurring vector retrieval by covering paraphrases, broad counters. And you can see you pass some constraints, and I tell the LLM to generate here 3 questions. Okay, I should pass here 3 questions, something like this, 3 questions. And then once the LLM generates these 3 questions, we are going to take it, we're going to take them, and then we are going to pass it, we're going to mark here, the next node here now should be the retriever node. And then we're going to take here these questions, we're going to pass it inside the rewrite queries array. Okay, this array. You can see we have a little difference, guys. As I pass an array, I pass a square brackets because the rewrite query state is an array. and I pass a string because the next node is a string. Okay, I think you get the idea. Okay, right here we use here structured output to get here to force the LLM to return here an array of questions, of 3 questions. You can see we pass here z.array, z.string, and length here 3 questions. Now after that, you can see we are here, okay, on the query run node. We are going to move now to the retriever. Okay, now we are going to move to the retriever node. You can see we have here retrieve docs. Now I'm going to take here this, I'm going to pass here query of states that rewrite queries. Okay, this is an array, and then I'm going to iterate through the array. I'm gonna pass you, I'm gonna retrieve the data for each question, and then I'm gonna take the data, I'm gonna push it inside the retrieve docs. Okay, we're gonna push it in here, and once we have your data, I'm gonna flat it into a single array. I don't want to get a multi-dimensional array. And then I'm gonna take here this array, I'm gonna copy it inside the retrieve document. This array, we're gonna put it these documents. Okay, now we're going to create here in a node, generate node, and here I haven't yet put in anything. We have here cons only. We are going to take here now this retrieve document. We're gonna pass to the LLM in order to generate the final response to the user. Okay, guys. Now you can see in here, we are here, generates. Okay, right here, we are going to get access to these retrieve doc that we got within the retrieve document state. We're gonna get access to it, and then we're gonna generate the response. Now you can see we have here the out of scope node. If the LLM classify the user input as out of scope, we're gonna move it in here, and then it's gonna hit here the end node. They're gonna say something like this. Sorry, I can't assist you with that. Okay, now we have here the graph. We're gonna build the graph, pass it the state, we pass it the state, the initial node, query run node, retriever node, generate node, out of scope nodes. Then from the starting node, we're gonna move to the initial node. Then here we have the conditional age here. You can see we have here this, and then from this conditional node here, I'm going to check here if the next node is equal to query write. We are going to return here query rewrite node. This is a router. This is a router node. Okay, this is a router node. Okay, this right here, this is a router node. We are going to check here if the LLM here return here something like here return query write. We are going to route the user to the query write node. If the LLM return here out of scope, we're gonna route here the user to out of scope node. And once we run the out of scope node, we are going to hit here the end node. So if the LLM here doesn't return here query rewrite node, or it doesn't return out of scope, we're gonna hit here the end node. I'm gonna return here the end node. Okay, and then here we have here now the another condition node. Now from query rewrite node, I'm going to check here if the mark here, the return here retriever node. If the mark the retriever node, we're gonna move here to the retriever node. Okay, if they don't mark here retriever node, we're gonna hit here the end node. You can see I return here end. Now if we move here, retriever node. Okay, retriever node here. Yeah, query run node. Let's move. Query run node. You can see in here pass the next node retriever node. Okay, as the mark here retriever node, we're going to move here. If they don't mark it, we're gonna move here. Let's say here, for example, here I passed something like this. They're gonna route us right here. They're gonna route us to the end node. Okay, because this is because they're gonna make a check, and then they're gonna see retriever node isn't the same. They're gonna route us to the end node. Okay. Now let's continue. Now you can see generate node here, it's the end node, and out of scope node is the end node here. The generate node here, this one, it's here the end node. It's here the end node. I'm gonna take that. We're gonna pass it right here. It's here, and out of scope node it here the end node. Okay, yeah, you can see pretty easy, guys. And then I'm going to compile the graph, and then I'm pass an input to the graph. Now I'm gonna run this, and you're gonna see what we're gonna get here. We're gonna have here retrieve documents, and also I console here the states. Let's run here this and see what we're gonna have here. And I'm gonna run this. Oh yeah, I'm gonna run here. Okay, we're gonna run this. Okay, I'm gonna run this. Okay, now let's see what we're gonna get here. Yeah, you can see next node here is query right. Okay, actually the graph is running. Oh yeah, we got data here, guys. We got data. Now let me see here. You can see generate response. Yeah, we run the generate node. Okay, actually we are here. Okay, actually we are here. Now let's see here the results. You can see we have an array of documents. This array. This another array here. Okay, we have a lot of data. We have a lot of data, guys. Okay, this data retrieved from the database. Okay, and at the bottom here, I don't see here the graph. Yeah, you can see here's the graph now. Here's the results of the graph. Okay, yeah, the graph starts here. You can see the graph. In the graph, we have here the message array. So you can see here we have human message. What is prompt engineering? Now we have here reroute queries. When we pass here this, they route us to the query right node in order to generate multiple versions of the user inputs. And then you can see definition and overview of prompt engineering in AI language models. You can see techniques and best practice for effective prompt engineering. How does prompt engineering improve performance of LLMs? Yeah, you can see they generate free versions of the user inputs. Now you can see here now the next node here is retrieval node. They're going to route us to the retrieval node, and then on the retrieval node we are going to retrieve data. We're gonna push it inside the retrieve documents. Okay, we're gonna push in the array. Now once we run once we push the data to the array, we are going to move here to the end node here, which is the generate node. We're gonna take here now these retrieve documents. Then we are going to pass these retrieve doc to the LLM so that the LLM can generate us a response. Okay. Now, in order to generate the response, I'm gonna use here a React agent. I'm gonna cut that. Okay, we're gonna cut that. We're gonna pass in here, pass that here. Okay, and pass that here. I consider you know what is a React agent. I'm pass a React agent. I'm gonna copy that. I'm gonna import it from LangChain. Pass edit tab here like this. And here, what I'm going to do next here, okay, create agents. Now I'm gonna pass here system prompt. For the system prompt, we got the system prompt inside the prompt.js. I'm going to copy this prompt, and then I'm going to pass in here like this. Now I'm gonna create a function that takes here these retrieve docs and then returns a string. Okay, I'm going to pass here this retrieve doc to string is equal to format document string. We're gonna convert it into a string. You can see we have here an array of documents, and then I'm gonna iterate through it and pass a document map, and I'm gonna get access to the page content property, and then I'm gonna return it. And once we have the data right here, we are going to take it. We're gonna pass it to the LLM. Okay. Now I'm going to do this. Let me head into in here. I'm going to copy here this. Okay, I'm gonna copy this. And then I'm going to pass it in here. Okay, right here we pass here user question. Okay, I'm gonna pass something like this. Okay, something like this, and pass here user. Yeah, and pass here user, and pass here user question. Okay, we're gonna take the user question. We're gonna pass in here. Something like this. I'm going to take here these generated queries. I'm take that, and then I'm passing here. Okay. Yeah, we are going to pass it right here. User questions. I can pass it something like this, and then I'm pass here this. We're gonna pass. Yeah, we're gonna pass here state. We're gonna pass state that. Pass here state that this. Okay, state that reroute queries. And then as the reroute queries is an array, I'm going to take here this, and then I'm passing here like this, that join. Okay, we're gonna convert it into a string, and I'm going to pass here now retrieve data. I'm gonna copy this, And then I'm passing here, I'm right here, retrieved data. Okay, I'm gonna cap this and then I'm passing here. And here's the retrieve data. I'm gonna take here, retrieve doctor string. I'm gonna cap that and pass it in here. Okay, we're gonna pass that right here. Okay, and then we're going to console here, console.log, and pass here final response. Yeah, like this. I'm gonna do something like this. Okay, and then we're gonna pass here AI response. Okay, great. And yeah, we just finished, guys. Now we're gonna run this and we're gonna get the response. Okay, now let's check this. Okay, we pass here the model and we have the model at the top here. Okay, let me check at the top here. You can see we have here cerebrus and we pass it in here. Okay, now let's run this and see what we're gonna get here. Let me get rid of this here. Let me get rid of this right here. Yeah, let me get rid of this. Yeah, something like this. Okay, now let's run this and see what we're gonna get. I'm gonna head into in here. I'm gonna run this again. We're gonna see what we're gonna get here, guys. Okay, you can see states query right. Okay, they generate multiple versions of the user input, and once they finish here, we're gonna get here the response. Yeah, we have here the document. Let me see here, generate response. Let me remove that. Okay, here if I scroll, yeah, you can see here we have the response, the final response. Okay, we have here the final response, definition and basics. Prompt engineering, also called encounters prompting, is the set of methods used to communicate with the LLM. Okay, you can see it's the final response, and in order to make it clear, I'm going to remove here this. I'm gonna comment this. I'm going to comment this, and let me see here something else here. Now let's run this again. We're gonna get something which is so clean here, guys. Okay, run this again, and here let's wait a bit. Yeah, they generate multiple versions of the user input, and then we're gonna get here the response. Let's wait a bit. Yeah, you can see we have here this. We console here. This is the graph. This is the graph here, guys. Here's the graph. You can see the bottom here. I pass here const.log. Okay, if I comment this, next time when we're gonna run this, we aren't gonna see this, but instead we're gonna see on the response, final response. Okay, you can see prompt engineering, also called encounters prompting, is a set of methods used to communicate with the LLM, so their behavior can be steered towards desired outcomes without changing the model's weights. It is an empirical practice focused on alignment and model stability. Yeah, you can see the response, and you can see best practice and techniques. Yeah, you can see we have the response. Okay, you can see it works pretty well. Okay, and congratulations, guys, you just built your first Q&A of a document workflow using LangGraph. Alright, guys, now we're gonna learn how to build a RAG pipeline. RAG stands for Corrective RAG. Corrective RAG is a RAG techniques where the LLM evaluates retrieved documents. Now you can see on this diagram we have here the user input. Once the user input once we have here the user input, we're gonna pass it to the query analysis node. We're gonna analyze the user input, and then we're gonna decide if we can route the user to the query route node. If we route the user to the query route node, we're going to take the user input and then we're gonna generate another version of it. And then here we're going to move the user to the retriever node, where we're gonna retrieve data from the vector database based on the user input. Now here we have here conditional age here, where we're gonna check here if the retrieved data is relevant to the user input. If yes, we are going to move the user to the generate node, or we're gonna generate the response based on the retrieved data. And then we're gonna add here the end node. If no here, we are going to take the user again here. We're gonna move the user here to the query route node. We're gonna take here again the user input, and then we're gonna generate another version of it. So once we have another version of the user input, we are going to move here again to the retriever node in order to retrieve data. Then we're gonna pass it to the LLM here in order to check if the retrieved data is relevant to the user input. If yes, we generate the response. If no, we continue here. Okay, you can see right here, we may end up in an infinite loop if we don't have here a condition. Okay, now here, I'm gonna pass here condition. Let's say we are going to retrieve data, we are going to reformulate the user input three times only. And after that, we're gonna add here the generation node. Okay, if we don't find any data, I'm gonna add here the generation node. For three times, if we don't find data, we're going to add here this node. Okay, now we're gonna get into the code and then we're gonna learn how to implement this. Okay, you can see this is a CRUD pipeline where we don't have here set2. For a second example, I'm gonna show you how to build a CRUD pipeline with a set2. You can see in here we have a set2 here. I here set2 where I pass a condition. If we don't find data in a vector database related to these generated inputs, we're gonna consider the search web node as a fallback. Now let's get into the code and see how we're gonna implement here the CRUD pipeline with our set2. Now let's head into the code here and see it works. Now in here, what I'm going to do, I'm gonna head into CRUD 01, okay, in here. Now, what I'm going to do first, we need here some prompts. I'm going to head into in here, and then I'm copy all these system prompts, and then I'm passing here, okay? And here, the bottom, I'm gonna add here another system prompt. Yeah, we're gonna use here this one for grading the user inputs. You can see in here we pass UI grader assessing relevance of retrieve doc to the user question. We have here some objectives. If the contents of the doc are relevant to the user's question, score them as relevant. Give a binary score, yes or no. Score to indicate whether the docs are relevant to the question. No, the docs aren't relevant to the question. Okay, this is the another system prompt that I just added. We're gonna use it for this node here. You can see we have a node for this node here. We're gonna use it in here in order to check if the retrieved data is relevant to the user inputs. Is where we're gonna use the system prompt. Now let's head into the CRUD 01.js. Now I'm gonna pass the model. We're gonna use here Cerebrus, and then here we're gonna pass here the graph state. You can see pass here the message that annotation is equivalent to this here, to the message array. It is the same thing. Now I'm gonna pass. Now we have here states rewrite queries. We're gonna store multiple versions of the user input. We have here the next node states. We have here the retrieve doc array. Now I'm gonna pass here the initial node, and then in here you can see we get access to the message array. Then here we're going to pass here. Now we're gonna invoke here the LLM. We're gonna pass here the system prompt, categorization system prompt, and then you can see here we pass here the system prompt. You are writing classify inside a structured LangGraph workflow. Your only task is to decide whether the user's question should be routed to the query run node or marked as out of scope. The system contains the following user documents: Book 1 prompt engineering and Book 2 autonomous agents or LLM powered autonomous agents. So in here, if I pass a question like what is RAG? Right here, I expert out of scope. You know, we don't have here this book. We're gonna get here out of scope. Okay, if we have a question related to prompt engineering or a question related to autonomous agents, they're gonna route us to query run node. Okay, now we're gonna return here the next node. We're gonna pass now query run node. We're gonna take the user input and then we're gonna generate multiple versions of it. I'm gonna generate here only one input. If I head into the chapter 3, you can see chapter 3, and I look for query run node. You can see in here we generate multiple versions of the user input here. But here in CRUD, I'm gonna generate here only one input, because once we generate only one input, we have the possibility to retrieve data. Okay, and then we can pass that to the LLM, and this data can be valid, and we can generate the response. But right now, I'm gonna generate here only one question, And if for this one question we don't have data, we are going to route again the user to the query run node in order to generate another question. Okay, this is the process that we're gonna follow. Now you can see if I head into the query route prompts, here you can see I tell here the LLM to generate only one query here. Okay, only one query here. And if for that query we don't find data, we're gonna generate another query. Now I'm going to pass here the condition. You can see here pass here reroute queries. This is an array, and then I'm checking if the length here is equal to 3. If the length here is equal to 3, we're gonna move the user to the generate node. It means we already hit the threshold of generating queries. You can see here, let's say for the first time here, let me remove this. You can see right here, if the user input, if the retrieved data is irrelevant, we're gonna move here again the user to the query run node. Let's say for the first time they generate a version of the user input. Then for the second time too, we don't find data here. We move here again. We're gonna pass it +2, +1 again. And again, we retrieve data. We don't find data. We're gonna move here, then +3, +1 again here is equal to 3. And then once we generate the user input for 3 times and we don't find data, we are going to E here. Immediately, we're gonna E here the generate node. Okay, this is the condition here. If we E here, we generate 3 versions of the user input and we don't find data, we're gonna E here generate nodes. Else, if we haven't here made a condition, we are going to move the user to the retrieve node. And then we're gonna return here these questions. Now, I'm gonna pass here the retrieval node, where we're gonna basically retrieve data from the vector database. And then I'm pass here now the generation node. We're gonna take here the retrieve data, and then we're gonna generate a response based on the user inputs. Okay, you can see we already implement that in previous chapter. Now I'm pass here _scope node. We move the user on this node in case the user input isn't relevant to the document that we got within our vector database. Now we're going to pass here the node grade node. Okay, grade node. This is the name of the node that we use in order to check if the retrieved data is relevant to the user inputs. And we are here, guys. Okay, we are here. Okay, right here. Now I'm going to pass here the LLM. Yeah, we're gonna pass here structure LLM, and then here the binary score here. Exporting here yes or no. And then I'm going to take here retrieve document. I'm gonna convert it to a string. Then here we're gonna pass here the grade system prompt. Okay, UI graders. Yeah, you can see we have here the system prompt, UI grader, assessing relevance of retrieve doc. And then here the LLM can retrieve yes or no. And then you can see pass here the user question, and then pass here the retrieve doc. And then here I pass here results, that's binary score. And then if score is equal to yes, we are going to move here to generate node. And then we're gonna E the end nodes. Okay. If here is equal to no, we are going to move here the user to the query writer node. And then I'm passing the graph. Okay, guys, I'm passing the graph now. This is the initial edge, the initial node that we pass here. And then I'm passing query writer node. And we have here some condition. Then I'm pass here gonna pass the grader node, and you can see here for the grader node I'm checking here the next node. If is equal to generate node, we're gonna return here generate node. If is equal to query write node, we're gonna return here query write node. And then you can see here generate node it's here end node, and other scope node it here end node. And now we're gonna compile the graph, and then we're gonna pass here this. And then I'll pass here question, what is channel thoughts? Now let's run this and see what we're gonna get here. Now I'm gonna move here, and then I'm gonna run this and pass here this. Now let's see what we're gonna get here, guys. And then let's wait a bit. You can see query write, retriever node here, finish retrieving. Yeah, you can see actually we have here yes. Yeah, for the first time they got the response. Now let me try to pass here something like what is corrective rag. I'm passing something like what is corrective rack. Let's see what we're gonna hear here. Yeah, continue. Okay, let's wait a bit. Okay, you can see binary score here is equal to no. Retrieve not. Okay, they are trying to retrieve data again, and then you can see grade not. Okay, binary score is equal to no. Again, they attempt to retrieve data, and here again, let's see, retrieve node here, finish retrieving, grade node again, binary score no. For 3 times they don't find data. For 3 times they don't find data, and now here we hear the end node. And then you can see final response here. I don't know based on the provided document. We don't find data, guys. We don't find data. Okay, you can see it's pretty interesting. We don't find data. So what if we are here to this pipeline? What if we are here a fallback? Let's say a tool that allows to search the web. You can see actually we don't find data. Let's in the doc we don't find data about this. Now, in order to get the data, we are going to add here another fallback, which is the search web node. Okay, you can see we have here search web. Okay, we're gonna add here fallback. Now, what I'm going to do here, I'm going to check here. Here we are going to modify the condition. We are going to check here. If we, for 3 times, we don't find data in the vector database, we are going to move here to the search web. Okay, we're gonna move here. We're gonna grab the data on the internet, and then once we have the data, we are going to pass it here to this node in order to check if the data is relevant. If yes, we are going to move now here to generate node, and then we're gonna generate the response. Now let's head into in here crack02.js. Now this is the same thing, guys. The same thing, same prompt, same system prompt. Here I just modify only the logic a little bit. Now we're going to, if I scroll a little bit, here you can see we have here the initial node. I didn't modify anything here. Query writer node, I modify here, guys. Okay. Now here I'm passive free. Now you can see passive condition if states that rewrite queries. You can see I'm checking for the length. If we already generate 3 versions of the user input and we haven't yet found data, we are going to route the user to search web node. And then I'm gonna empty here the retrieve document. You know, once we retrieve data, you know, let's say, you know, here we have here the retrieve doc. Once we retrieve data in a vector database, we push the data here. I retrieve the data for the second query, we push data here into the array. We retrieve data again here, we push that here. So if we retrieve data 3 times and we don't find data, I'm going to empty that, the array, I'm gonna empty that, and then I'm gonna route the user to the search web node. And once we have the data from the search web node, we're gonna push the data into the retrieve document. And now you can see here we have the retriever node. I don't modify anything in here, guys. I'm going to move here to the generate node here. This node allows to generate a response based on the user input. Okay, I don't modify anything here. Okay, I didn't modify anything. I'm gonna close this. And out of scope, grade doc, grade node here. I don't modify anything in here. Now we're gonna move here to search web node. Now for this node, I use here exa. This is an API in order to go on the internet and grab data. Now in order to get the exa key, head on exa.ai and create an account, then head into API key, and then you're gonna get your API key, and then you're gonna pass it here. Okay, now I pass the exa. Let me show you first here at the top here. You can see in order to use it, I import here exa results and I import here exa. Okay, you can say I import this. Now let's go at the bottom here. Okay, we're gonna move here. You can see we pass here a tool. You know what is a tool. Now you can see we pass here the query. And then here we invoke here the tool. You can see right here we invoke the tool and I pass it one query here. I pass here the last generated query. Okay, you can see pass the state that rewrite queries, that's pop. I extract here the last generated queries. Then I pass in here. Okay, now we're going to make a web search, and once we have the data, I'm gonna create here a document, and then I'm going to take the doc and pass it into the retrieve doc array. Okay, we're gonna pass in here. And then here you can see I pass here something like this. From search web node, we are going to move here to the generate node. Okay, now we're gonna pass here this kind of question again. Let me pass you this. Let me pass you this. What is corrective rag? Let's see what we're gonna get here. And here, let me run this first. Let's see what we're gonna get here. Yeah, we're gonna run here. We're gonna run here crag02. Okay, let's wait a bit. Query write. Okay, they are rewriting the user input. Okay, yeah, they're grading doc. Here you can see binary score is equal to no. Retriever node again, and yeah, you can see actually they're grading, yeah, no, we got no here is binary score. Now you can see they are trying to retrieve data again. You can see we got binary score is equal to no again. Now we are going to eat the fallback. The fallback is the search web tool. Now we're gonna find data from the innards, and then you can see, yeah, we have here the response. Here you can see actually we know what is corrective rag. Corrective rag, Retrieval-Augmented Generation. Yeah, you can see corrective Retrieval-Augmented Generation is a plug-and-play extension of standard Retrieval-Augmented Generation pipeline that self-corrects retrieval errors before the LLM generate response. Okay, you can see we have the response because we use here the search tool is a fallback. You know, in our documents, we may miss data. Now, as we miss data, we move to a fallback, okay? You can see this how it works, guys. Is pretty simple. Pretty simple. What you need to do right now, guys, is to practice. If you don't understand how it works right now, don't worry. It is a matter of time you need to practice. What you have to do here is to start here, understand how this works, okay? Move on chapter 2. Understand how a graph works. Try to create here something trivial. Something like this, node A, node B. And then once you understand this, you're going to move to chapter 3. And you have to make sure you have the basic of LangChain, okay? Make sure you got basic. And once you got the basic, you're going to come here. You're going to try to do that from scratch. Isn't difficult, guys. It's pretty easy. And then once you finish, you're going to move here, and then you're going to understand everything. All right, guys, now I'm going to talk about self-rag. Self-rag is a rag technique where the LLM does self-evaluation and self-reflection of its own response. You can see here, guys, we have a rag pipeline here. Now we have here the query analysis node. This is the first node. Before the user input get into the system, we need to pass it in here. Now once we pass in here, we're going to decide if we can route the user input to the autoscope node or to the query run node. If we route the user input to the query run node, we're going to generate another version of the user input that we're going to use in order to retrieve data from the vector database. Then here, we run the retriever node here. We are going to retrieve data. We're going to pass it alongside the user input. And then the LLM is going to decide if the retrieved data is really relevant to the user input. If we have here yes, if we got here yes, we are going to move here to the generate node. If we got here no, we are going to move here. We're going to move again to the query run node. We're going to generate another version of the user input. And here we can use a retrieval node or a search web node in order to get data. So once we have the data again, we're going to pass it to the grade document node in order to check if the retrieved data is really relevant to the user input. And then here the LLM can return again here no or yes. If the LLM return here yes, we are going to move here to the generate node. We're going to take now the retrieved data alongside the user input, and then we're going to generate the response. So once we have the response, we're going to move here again to another node, which is the hallucination checker node, where we're going to take the response, which is the generated results. we are going to check if it doesn't contain hallucination based on the user inputs. If it doesn't contain hallucination, we're going to generate a response immediately to the user. If yes here, we are going to move to the query run node here. Then we're going to generate another version of the user inputs. And then we're going to use it in order to retrieve data with the retriever or with the search web nodes. And once we have the data again, we're going to grade it. Then in here, we're going to move to the generate node. We are going to check again the data if it doesn't contain hallucination. If it doesn't contain hallucination, we are going to generate here the response. That's how a self-reflective RAG works. You can see here we have self-evaluation, we have here self-evaluation, and we have here self-reflection. Self-evaluation occurs when the LLM here grades the retrieved data. And self-reflection occurs when the LLM check its own response and then evaluate it. That's how it works, guys. Now, in order to understand this better, we're going to get into the practice. Now, I'm going to head into in here, guys, and then we're going to copy everything in here in the chapter 4 about corrective RAG. We're going to pass it into the chapter 5. Now, we're going to pass another assistant prompt, hallucination checker prompt. You are an assistant whose sole job is to decide whether the serial retrieve passages supplied by a Retrieval-Augmented Generation pipeline can safely answer the user's question without any hallucination. Now we pass here some procedures, read the user's question, and identify the essential facts or answer type it requires. Examine every retrieve passages, decision rules, and here's the prompt, guys. Okay, this is the prompt that we're going to use in order to check for hallucination. Now I'm going to head into the self-RAG pipeline here. We're going to import here first some packages and system prompts. Then here, I'm going to pass here the model, and we're going to pass here our graph. Okay, you can see if I head into the chapter 4, I head into Corrective RAG 2 here. If we have a look to the state here, I copy this, and then I pass it in here inside the self-RAG.js file. I don't modify anything here. Now I'm going to pass you the initial node like it is in chapter 4. I don't modify anything in here. We're going to pass here now the query run node in order to generate another version of the user input. We pass a condition. If we already generate 3 inputs of the user input, I'm going to redirect the user immediately to the search web node in order to grab data from the internet. Else here, we're going to redirect the user to the retriever node in order to fetch data from the vector database. Now we have here the retriever in order to get data from the vector database. Now we have here now the generate node. We use the node in order to generate a response to the user based on the user input and the retrieved data. You can see pass here the generator. You can see pass here the user input, and we pass here the retrieved data. You can see in here we update here the generated answer state. We're gonna pass here the response. Now we're gonna pass another node, hallucination checker. In here you can see I pass here an enum type here. Here the LLM is gonna return here yes or no. If the generated response contains hallucination, the LLM is gonna return here yes. If it doesn't, the LLM is gonna return here no. And you can see we pass here the user input and we pass here the generated response. Now in here I'm checking if the response is equal to yes, we are going to route the user to the query run node in order to generate another version of the user input that we're going to use in order to grab the data on the internet. Then here I'm going to pass here the autoscope node, and we're going to pass here the gray node. And here now we have here the search web node. I didn't modify anything in here. For this node. I didn't touch anything from here, guys. I only modified the node here. I only add this. Okay, I only add the hallucination checker. Okay, now we're gonna pass here the set node here. You can see pass in here. Now I'm pass here the graph, and we are going to pass here now the hallucination checker. You can see we pass it here, and then I'm gonna pass here these conditions, and here you can see hallucination checker. We have a condition states that next node is equal to query right. We are going to redirect the user to the query right node, and here we're gonna pass here set web node. From the set web node, we're gonna move to the generate node. From the generate node, we're gonna move here to the hallucination checker. Once we generate a response, we are going to move immediately to the hallucination checker. And then from auto scope here, we're gonna add here the end node. Okay, that's how it works. Okay, that's how it works. You can see pretty simple. And then here you can see we pass here now the input, what is corrective rag. Now I'm gonna head into the console and we're gonna try this. We're gonna see how it works. And here we're going to run here chapter. Let me see here we're gonna run here chapter 5. I'm gonna move here, and then we'll pass the nodes, and then we'll pass the chapter 5. Okay, we're gonna wait a bit. Yeah, you can see actually we rewrite the user input. We generate another version of it for better retrieval. Then here you can see binary score is equal to no. We don't find data. Then we try to retrieve data again. We have here no again. We try it again for the last time here. We have here no again. I think we're gonna get here no again. No. Now we're gonna try to move. We're gonna head on the internet in order to fetch the data. And you can see from the internet here, we get the data here. You can see web search and web search. Then here, generate node here and generation node. Then we move to another node. We're gonna check for the hallucination. And in here, it seems we didn't have here hallucination. As we don't have here hallucination, we are going to hit the end node immediately. They're gonna generate the response. Now you can see we have here the response. If we move at the bottom here, let me scroll all the way to the bottom. Now you can see here, guys, we have the response about corrective rag. You can see we have here corrective rag, we have here the definition, and we have here some key ideas about corrective rag. Okay, you can see we have here the response. It doesn't contain here hallucination. The LLM already checked it. And you can see that self-reflective rag is an amazing technique that we can use in order to improve the quality of the generation, the quality of the retrieval. Okay, this is self-reflective rag. It allows us first to evaluate the response, then we are going to check later for the hallucination. Okay, you can see self-reflective rag is an amazing technique, guys. Okay, now in order to understand how it works, you have to practice, try to practice. Once you practice, you're gonna understand everything. You're gonna understand literally everything, guys. And I see you in the next one. Thanks. Alright, guys, now I'm gonna talk about adaptive rag. Adaptive rag is a rag technique where we choose the best path in order to answer the user input. Now you can see we have here the design of the system. We have here the query analysis node here. If we pass an input like what are trending now in AI, we are going to route the user input immediately to the web here so that we can get data. If we pass this kind of question to our RAG system, we are going to make here unnecessary steps. We're gonna lose time and we're gonna consume a lot of resources to our system because we aren't gonna find data. You can see if we pass this kind of question to our previous system, we are going to, first of all, we're gonna try to generate multiple versions of the user input. Then we're gonna try to fetch data. We are going to get here binary score is equal to no. Then we're gonna try it again to fetch data. We're gonna get here binary score is equal to no. And again, if we have here binary score is equal to no, now we're gonna try to route the user input to the web in order to get data. Now you can see in here we run through some unnecessary steps here. Now we're gonna fix this, guys. You can see this is our previous system when we talked about set rag here. And in here too, you can see we have here the query analysis node. But here you can see after this node, we have here two nodes, two child nodes here. We have query analysis, we have here query run node here, where we can take the user input and generate a new version of it. And we have here auto scope. Let's say we pass you this kind of question, what are trending now in tech? Maybe our system can route us to idoscope node and we aren't gonna get data. If our system route us to the query route node here, we are going to try to feed data in our system, and if we don't find data, at the end they're gonna route our user input to the web in order to get data. Now we are going to fix this. Instead of running to these kind of unnecessary steps, in here we are going to route the user input immediately to the right source so that we can get data. Now I'm gonna get into the code in order to show you how to implement this. Now you can see we have here chapter 6 and we have here Adaptive-React.js. Okay, I copy everything in here inside the self-React.js and I put it inside the Adaptive-React.js. And here, if we head into the prompt.js, I add here another system prompt. You can see query analysis system prompt here. You are an expert at writing a user question to a vector store or website. The vector store contains documents related to Book 1, Prompt Engineering, and we have here Book 2 that talks about autonomous agents. Use the vector store for questions on these topics, otherwise use web search. Now, this is the system prompt I'm going to pass here to this node right here. I've added here another node here, query analysis node here. And I'm expecting here a website is the next node or vector store. If we have here a website, we're going to head on the internet in order to grab data. If we have a vector store, we're going to try to retrieve data from our vector database. Now we have here the initial node. I didn't modify anything here. We have here the query route node. I didn't modify anything here. We have here retrieval node. I didn't modify anything. We have here generate node. I've added here something, this line here, in order to get the last human input. And then I pass it in here. You know, as we aren't gonna move here, as we aren't gonna move to the query route node here, we are going to get here empty. Okay, you know, if I head into here, let me head into here. Let's say I head into here. Let me show you something. If we have something like this, const x is equal to an empty array, and we have here that join, and then I pass here this. Okay, we are going to have here an empty string. Okay, if I type here x, yeah, you can see we have here an empty string. Now, as we got here an empty string, I'm going to pass here now the human input, and then we're gonna use it in order to generate the response. And you can see too, I pass here the same line to the hallucination checker node here. I pass that here, and I apply the same technique. If we don't have anything here, we're gonna pass here the human input, and then we're going to check for the hallucination. And now you can see here we have now the gray node. I didn't modify anything in here. We have here the set web node. I pass here the line to in order to get the user input, and then we pass it to the set tool. You can see here's the set tool, and then we pass it in here. If we don't have anything inside this array, we're gonna get here the user input, and then we're gonna pass in here, and then we're gonna grab the data from the internet. And you can see now we pass here this node, query analysis node, and here we pass it as the starting node. And you can see we have a conditional age here. If the next node is equal to web search, we're gonna head on the internet. If is equal to vector store, we're gonna head on the initial node. Okay, that's how it works. Now I'm gonna head into browser, and you can see we have an input. What are trending now in tech? They're gonna take us on the internet. Now let's try this. I'm not heading to here. Let's try to move here, and we're gonna try to retrieve the data. I'm tap inner. Now you can see actually we have an error. I'm gonna move here to fix that. Let me check here this. We're gonna head on right here. We got the error. Okay, right here. Let me check here. Yeah, here guys, you can see we have here an error. Yeah, on line 158. State passes states that redirect queries. Okay, we don't have here an error. Let me check again here. I'm gonna go back here and I'm trying to run this. And yeah, you can see we have a space problem. We have a space problem. Now I'm gonna add it here. Okay. Let's run this again and see what we're gonna have here. And run this. Yeah, we got the same error here on chapter 6 adaptive RAG.js. Okay, query rewrite. Yeah, you can see we have here space. I don't know why we got that space there. Yeah, you can see state that query rewrite. Yeah, you can see states rewrites and passive rewrites queries like this. Maybe we're gonna fix that error. Okay, let me look for the error here. Let me check here. Okay, right here no error, and here no error. Yeah, we're gonna run this again. Okay, I'm gonna run this. Yeah, now we are retrieving the error. Let's wait a bit. Okay, yeah, you can see actually we have here web search, and in web search generate note here, we generate the response based on the user inputs. Then we check for hallucination, and then we have here the answer. You can see we don't jump to a lot of unnecessary steps here, guys. We got immediately the answer. We route the user input to the right source. And you can see we have the response. The current year trends highlighted for 2026 are, you can see deflection of the A bubble. Yeah, you can see we have the results. Now let me try to pass here an input like what is prompt engineering, and pass here what is prompt engineering, and pass here what is prompt engineering. Let's try to see what we're gonna get here. Okay, I'm tap here inner. Let's try to see what we're gonna get here, guys. Yeah, you can see the routers on the query run nodes here. Now we're gonna generate multiple versions of the user input. You can see we have here data from our vector database here. And then we check here for the hallucination. And as we don't find here hallucination, we have here the answer. You can see prompt engineering. Yeah, we fetch data from our vector database. You can see our system works pretty well. And yeah, if you have some issue, guys, try to practice in order to understand this pretty well. Try to practice. In order to understand this stuff, you need to practice. A little practice, so you're gonna understand everything here. And yeah, we just finished, guys. We just finished everything. I think right now you are comfortable with RAG, because I just covered everything you need to know about RAG, guys. Try to practice. Now we're gonna talk about a reflection. So what is reflection? Reflection is when the AI reverses its own output. You know, the LLM can generate the response. Now the LLM here, it's gonna reverse, it's gonna check if you don't have irrelevant data. Now you can see here's the process here. We have here the user. The user pass here an input to the LLM. Then the LLM here generate an initial response. Now we are going to take this initial response, we're going to pass it to the LLM so that the LLM can reflect on it. Now, once the LLM reflects on it, the LLM is going to generate criticism. Yeah, you can see we have here this criticism. Now, once we have here this criticism, the LLM is going to use here this criticism in order to improve the response. That's what we call reflection. Now, in order to understand this better, we're going to get into the practice again, guys. And now we're going to head on the chapter 7 here. I'm going to head into, first of all, I'm going to present you the prompt here. And if I move at the top here, you can see we have here a prompt in order to, now you can see here we have a prompt in order to generate an essay. You are an essay assistant tasked with writing excellent 5-paragraph essays. Generate the best essay possible for the user's request. If the user provide critique, respond with a revised version of your previous attempts. We have here the reflection prompt. You are a teacher grading an essay submission. Generate critique and recommendation for the user's submission. Provide detailed recommendation including requests for the length and depth style. This is the prompt for the reflection. We have here now the revision prompt. We are going to use here the prompt in order to check here if the generated essay is pretty good. We are going to take the generated essay and then we're gonna apply corrections. Now you can see you are an expert academic editor and revision specialist. You will receive an essay draft, a detailed critic and recommendation. Your task is to carefully write the essay by applying the reflection, and we pass you some instructions. We're gonna use here the system prompt in order to improve the generated essay that we're gonna call the draft. Now we're gonna head into the reflection digest, guys, and in here you can see we have a basic graph here. Okay, you can see here's the basic graph. We have here the generated essay. Once it generates an essay, we're gonna keep it inside the state here. We have here corrections. When the AI generate criticism, we're gonna put it into the corrections states here, and we have here the final essay states. Now you can see we have here the generate nodes. We use the generate node in order to generate essay. You can see we invoke here the LLM and pass it the system prompts. Once the LLM generates the essay, we're going to move here to the next node, which is the reflection node, and we're gonna pass here the generated essay. Now I'm gonna run this. I'm going to comment right now this. I'm gonna comment this. I'm commenting this node and these two here, and we're gonna see how it works first. Okay, I wanna show you everything first here. I'm gonna comment these two. Okay, like this. I'm gonna comment these two. Now what I'm going to do in here, guys, I'm gonna comment here these two here, and then we're going to see how it works. I'm gonna comment these two lines here too. And here I'm gonna copy this and pass in here. You can see the generate node here, here the end node. When we're gonna run this, we are going to generate an essay immediately. You can see pass here an input, write an essay on how artificial intelligence is shaping the future of work and society. This is the input. Now let's head into the prompt and run this. Now we are going to head into chapter 7 and pass here chapter 7. And here we're gonna head into part 1 / and pass it part 1 like this. And here for the file name, we're gonna pass here. Let me pass here reflection digest, and then tap enter. Let's see what we're gonna have here. Yeah, you can see we have here generated essay. You can see it's the graph. Inside the graph, you have here only the user input. Write an essay on how artificial intelligence is shaping the future of work in society. And we have here the generated essay here. This is the generated essay. Now, once we have here this generated essay, we're gonna use here the AI in order to generate criticism. Now, I'm going to generate now criticism. Criticism, you can take it as corrections that we're gonna apply to the essay. Now, I'm now comment this, and now we're going to move here from the generate node to the reflection node. I'm gonna copy this. This one, it's gonna be here the end node. And here I have here a node here, a reflection node here. This is the node that we use in order to generate reflection. I'm not uncomment this, and you can see past here the system prompt here, and I'm using here React agents, and I pass here generated essay. Now we are going to ask the AI to generate criticism. Now let's run this and see what we're gonna have here. Okay, let me uncomment this like this. Okay, everything is ready now. Let me run this again. You're gonna see we're gonna have here something. Let's run this. Let's run this. Yeah, you can see actually we got the response in here, guys. You can see at the top here we have the generated essay. This is the generated essay here. And you can see now we have your criticism. Now here the AI generate some correction that we need to apply to the essay, and we have here the strength of the actual essay. And here the AI continue, and here you can see we have here another point, organization and structure. What works well? What could be? You can see we have here what could be tightened. You can see if we continue, you can see we have here style and voice, and you can see at the bottom here we have some corrections. Okay, you can see we have here the A is checking even the length of the words. You can see right here, the A suggests here this. Okay. If I continue the bottom here, you can see we have here the criticism generated by the AI. Now we are going to use here this criticism in order to improve the generated essay. Now I'm going to move here again. We are going to move here now on the generate essay final note here. I'm going to uncomment this line. And then we're going to pass here, we're going to pass to the LLM the generated essay. And then we're going to pass here these corrections so that the LLM can improve its own answer. Now I'm going to uncomment here this line here. And then we're going to pass it the line. And then we're going to take here the generate final essay node. We're going to pass it as the end node, like this. Now let's run this. Let's run this again. I'm going to run this again. Let's see what we're going to have here. Now we are going to generate an essay, and then the LLM, it's going to use here these corrections that we call criticism in order to improve the generated essay. Now you can see at the bottom, at the top here, if I move at the top, you can see here's the generated essay. If I scroll bottom, you can see we have here the essay. Now the AI generate criticism here. Now we're going to apply this criticism. Now if I scroll at the bottom here, you're gonna see we have here the final essay. The AI apply criticism. If I scroll at the bottom, you can see the AI add here reference. You can see we have a reference at the bottom here. The AI improve the essay. Okay, you can see this is how it works. It's pretty simple, guys. You can see this, that's what we call reflection. Reflection is when the AI generate an answer and then reflect on it, revise it, and try to check if it can improve it. Okay, you can see in here we have the user. The user pass an input to the LLM generate an initial response, then the LLM is going to revise it. It's going to generate thoughts on it and checks if this is the right essay. And after that, it's going to generate here criticism. Okay, and then we're going to pass it again to the LLM, and then we're going to generate the final answer. Okay, that's how it works. And that's what we call reflection. Now we're going to talk about another type of reflection that we call reflection. Alright guys, now we're going to talk about reflection. Reflection is another type of reflection where the LLM generates an initial response with criticism and search queries in order to improve the response. Now you can see in here guys, we have here the user. The user passes here the query to the LLM. Then the LLM here generates the initial response. Now, as you can see here, you can see in the response we have here, in the initial response, we have here the response, we have here the criticism, and we have here the set queries in order to improve the response. Now, the LLM is going to use here, let's say, a set tool. It's going to take here these set queries, it's going to use it in order to grab data on the internet, and then once it has the data, it's going to use it in order to improve the response. Let me give you a trivial example. Let's say I give you a question. Let's say I give you a question. Let's say I pass here, I pass you this kind of question. What is prompt? I'm passing what is prompt engineering. Okay, I give you this question. What is prompt engineering? Now what you're going to do is to generate an initial response here. You're going to generate here an initial response. Now, once you generate an initial response, you're going to revise this response. You're going to generate here criticism, and you're going to identify gaps in the response. Now, here we're going to have here gaps. I'm going to say here we have here gaps. Now, once you identify gaps in your response, you're going to generate also some set queries that you can use in order to improve your response. Now, you can generate here some set queries. You're going to pass here some set query that you're going to use in order to improve the response. That's how reflection works. Now, let's get into the code in order to understand this better. Now, we're going to get into in here. And you can see we have here chapter 7 and here part 2. And we're going to head into reflection. Now, what I'm going to do in here first, I'm going to comment everything here. I'm going to copy this. And then I'm pass at the bottom here. I'm going to comment this line here. And I'm going to comment this. I'm going to comment this. Okay, we're gonna stay with one node first, and then we're going to see it works, and then we're gonna add other nodes later. Now you can see we have your nodes that we use in order to make a request to the web, and we use here exact search. I'm gonna comment this right now. I'm gonna comment this, and I'm going to comment here to this node here. This is the revision node here. I'm gonna comment this. I'm not getting to that later. And right now we're gonna focus on one node, the initial node only. I want you to understand the initial node, and then we're gonna move on to other nodes. Now you can see at the top here, we pass here the LLM, this is the model, and we pass here the state, reflection states. We pass here the message annotation, a message annotation.spec, which is this array here, an array of message, and we pass here the current step. This is gonna be a string here. Okay, this is gonna be a string, and we pass here search results. This is an array. Now you can see we have here the initial node, and at the bottom here we pass here an input. What is prompt engineering? Now we're going to take here that input. We're gonna pass it to the initial node. Now you can see we have here the LLM with structured output, and then I pass here answer question schema. Let's see the schema here. Answer question schema. Yeah, this is the answer question schema here, guys. You can see is right here. Now you can see once we pass this kind of question, what is prompt engineering? The LLM here, it's gonna generate here the answer, and it's gonna generate here the reflection. Now inside the reflection key, inside the reflection property, we're gonna have here missing, I can say criticism, and we're gonna have here superfluous, unnecessary content the LLM can add in the response. That's what we call superfluous. Now we are going to use here the schema. We're gonna pass it to the LLM here. Then we're going to pass here the system prompts. You are expert researcher, current time, and we pass it the current time. We pass here provide a detailed 250 word answer. Reflect and critique your answer. Be severe to maximize improvements. Recommend search queries to research information and improve your answer. Now you can see pass it the system prompt, we pass it the message, and we pass it the row. We pass here a user message, reflects on the original question. Now let's head into the console here. We're gonna try this. I'm gonna run this, and we're gonna have here the initial response. And once we have the initial response, we are going to use it in order to improve the answer. Now you can see we have here the initial response. Prompt engineering is a practice of designing and refining and optimizing textual inputs called you can see we pass here input called I can see pass here prompt to elicit desired output from generative AI models such as LLMs. Now you can see it's the initial response. Now you can see in here we have reflections. The LLM identify gaps in its own response. Now you can see the answer lacks concrete historical context. And you can see we have here superfluous. Superfluous are unnecessary stuff that the LLM add in its own response. Now you can see the paragraph on the commercial settings repeats ideas already covered in the description of applications and could be trimmed. Okay, you can see we have here superfluous. And we have here some set queries the LLM can use in order to improve the response. History of prompt engineering, GPT-2, automated prompt generation techniques, prompt injection attacks and mitigation. Yeah, prompt injection attacks and mitigations. Now you can see we have here some set query the LLM is going to use in order to improve the response. Now what I'm going to do, guys, I'm going to uncomment here now the revision node. Okay, this node here, and I'm uncomment here the search node here. Now you can see on the graph will pass here the initial node. Now we're gonna pass here the search node, and we're gonna pass here the revision node. Now once we run here the initial node, we generate the initial response. We are going to move to the search node here. Okay, you can see from the initial node to the search node, and then from here we are going to head on the internet. We're gonna head on Google, and we're gonna use here the search queries in order to get data from the internet. And once we get data from the internet, the LLM is gonna use the data in order to to improve its own response. Now, once we have the data, we are going to move from search to revise in order to improve the response. Now you can see if I head into, let me head into first here, you can see we have here the search node here. Now we take here these generated queries. You can see states, that's current state, that's set queries. You can see we got this here, states. Okay, you can see we have a current state here, and then we have here, we're gonna pass here state, you're gonna pass a state, that's current state, and then that set queries in order to get access to this array of queries. Now we're going to use here these queries. You can see we have queries. Now we pass the exact search. Now pass here for const query of queries. Iterate through the queries array, and then I'm passing here. Once we have the data, we are going to push it inside the raw results, and then we're gonna take the raw results. We're gonna pass into the set results right here. Now we're going to move here to the reversion node here. Now from here you can see pass the system prompt. You are an expert researcher. We pass the current time. Now we pass here. We pass here new reset data, and we pass here states that set result. You can see actually here the set results array is empty. When we're gonna move to the search node, we are going to pass here some data. Now we are going to take the data. When we're gonna move to the reversion node, we're gonna take the data. We're gonna pass to the LLM, new reset data, your task, pass here your task, revise your previous answer using the new reset data above. Address the specific gaps. Okay, these are the gaps. We pass here the criticism, and remove these superfluous. And we pass here current, that's reflection superfluous. And you can see use numerical citations like based on the sources provided. Provide a new critic and further search queries if the answer still isn't perfect. And then you can see pass the system prompts and the user input. Update the answer using the provided research response using the reverse answer. Okay, you can see here's now you can see here's the reversion node. Now we're gonna run this and see what we're gonna get here. Now I'm gonna head into here, and then I'm gonna run this, and you're gonna see the first thing the LM is gonna generate the initial response. Then it's gonna make here, it's gonna generate criticism and set queries that we're gonna use in order to improve the answer. And once we have data, we got data from the internet. Now the LM is gonna use internet data in order to improve the response. You can see actually we have here a lot of data from the internet. So you can see, yeah, you can see we have a lot of data. Okay, you can see search results. We have here a lot of data, guys. And now if I move at the top here, you can see is the inputs. Now you can see is the initial response here. Okay, and then here is the final answer. You can see the LLM here first generate the initial response, and then if I move here, you can see we have here the current answer. This is the current answer here. Now you can see at the bottom here, we have here some missing. The answer does not include the concrete cause analysis example from the Reforge case. Okay, it doesn't contain this. And we have here superfluous. The metric table repeats information already covered in the code technique section. Now we have here some set queries. Now we have here some set queries that we make in order to get there from the internet. And we have here some references. Okay, now you can see here's the final answer. Okay, here's the final answer here. This is the initial answer here. And here's the final answer. You can see the final answer is pretty big here. It covers a lot of stuff here. Okay, you can see it covers a lot of stuff. Now, to conclude, guys, you have to know that reflection is a type of reflection where the LLM generates the response and the criticism and set queries in order to improve the initial response. That's what we call reflection. Alright, guys, now we're gonna learn how to build a multi-agent system using Handoff Pattern. So, what is Handoff Pattern? Handoff Pattern is a multi-agent system where the sub-agent can interact with many agents. Let me give you an example in order to understand this pretty well. Now, I'm going to draw here a chart. Okay, first of all, I'm pass here a supervisor pattern. This is how a supervisor pattern in multi-agent system looks like. Okay, we have here sub-agents and the many agents. Let's say I pass here an input to the many agents. Now the manage agent, it's gonna call here a sub-agent. You can see here we have a sub-agent. Now once you call the sub-agents can have here set tool. It can go on the internet and grab data. And once it has data, it's gonna pass it to the manage agents. And then here the manage agent can interact now with the user. If the manage agent again needs to call another sub-agent, it can call here the sub-agent here, and this sub-agent can work. And once it finishes working, it's gonna give here the results to the manage agents, and then the manage agent is gonna give the feedback to the user. That's how a supervisor multi-agent system works. Now let me show you how a multi-agent system where we use the handoff pattern works. Now you can see here we have the manage agent, and the manage agent here has two sub-agents here. Now if I pass here an input, we have here the user pass here an input to the manage agents. Now the manage agent here, it's gonna call here the sub-agent. It's gonna delegate here. It's gonna delegate the task here to the sub-agent here. And once this sub-agent finish working, it can give here the response back to the user. Okay, it's this sub-agent here. You can see that actually it interact directly with the user. You don't have to pass the data to the manage agents. Okay, you can see that's what we call handoff pattern. This sub-agent can interact directly with the user. Okay, that's how it works. That's how handoff pattern works. Now you can see here we have a system, a handoff pattern system. Now we have here the user, we have here the manage agents, we have here the reset agents, and the summarize agents. If I pass here a question like hello, here the manage agent is gonna handle that. Okay, if I pass here hello, the manage agent is gonna respond immediately. You can see pass here an input, and then the manage agent here responds. If I pass a question like what is the kind of weather, now here the manage agent here is gonna delegate the task here to the researcher agent here. It's gonna call here this, and then once it has here data, the research agent is gonna delegate the task to the summarizer, and then here the summarizer is gonna summarize the data, and then it's gonna give here the results back to the user. That's how handoff pattern works. Now in order to understand this better, we're gonna head into the practice, and we're gonna build a multi-agent system using handoff pattern. Now you can see here we have the prompt.ts. Now in here I'm passing you the prompt for the manage agent. You are a professional project manager. Your job is to interact with the user and delegate tasks to your sub-agents when necessary. You have two sub-agents. Research has a tool to search the web for real-time information. Summarize researches and pass some guideline. We're gonna pass here the researcher prompt. We're gonna pass here the research assistant prompt. You are expert research specialist. Your goal is to use the search tool to find the most accurate, up-to-date, and relevant information based on the manager's instruction. I'm passing our system prompt, the summarizer prompt. You are a senior content summarizer. Your job is to take raw research data and transform it into a clear, concise, and helpful response for the user. Now I'm gonna export here the manager prompt, research prompt, and summarizer prompt. We are going to head into now the tool, the TS, and then we're gonna pass here our tool. This is a tool. Now I'm going to head into the multi-agent system, the JS, and then in here I'm going to pass here now the graph. Okay, we pass here first of all we need to pass it model. Then here we are going to pass here a function that allows us to create a React agents. Now you can see pass here create agents, and we pass it the model, we pass it the tools array and the system prompt. Okay, you can see we have here an object. Then here we invoke the model, and then here we return here the message. Then we're gonna pass it the graph, and here you can see we have it manage agents. Then I'm going to extract here the last human input, and then I'm passing it to the manage agents. Then we're gonna pass it console and node manager. Then I'm going to check here should handoff AMS that content includes requests. You can see here if I head into the system prompt, at the top here you can see we have here a guideline. To delegate to the researcher, your response must include the word request followed by a clear instruction or what to search for. Yeah, this is the instruction that I pass here. Now if we go back here, let me go back here. You can see in here I'm checking if the manage agent's response includes here request, we are going to move here. We are going to route here to the researcher agents node. Okay. Now you can see I'm passing here a function command. Now the command function here updates here the message states, update a state, and it routes here to a node. First, we are going to update the state here, and then we're going to route to the research agent node. Okay, that's how the command function works. Now you can see, in order to understand how the command function works pretty better, you can try to copy this. You can see we have here a graph, a little graph. We have here node A. Okay, you can see we have here node B, node C, and you can copy this in order to understand how this works. Okay, copy this. This you can see here we have even little comments. The command function updates the graph states and send messages to the node. That's how it works. Okay, pretty easy. Once I pass you the A message, we're going to update here the message array, and then we're going to route to the research agents. Now, if we don't have here this, the AMS doesn't include here request, we are going to update here the message. We're going to update the message array, and then we are going to add here the end node. Then I'm passing another agent here, research agents, and then we are going to extract here the manager agent response. You can say pass here state that message, and message type here is equal to AI. Then I'm going to pass it the system prompt, and here we're going to pass it the message, and I'm passing it tool, say tool. Then we're going to console here this, and then we're going to update here the state, and then we're going to route to the summarize agents. Now I'm passing the summarize agents. We are going to extract here the last A message. Once the research agent responds, we are going to extract here, we're going to extract the data, and then we're going to pass it to the summarizer. Okay, we're going to pass it in here, and then we're going to update here the message array. Then we're going to add here the end node, and then we're going to pass here a graph, and then from the starting node we're going to move to the manager node. Then from the manager node here we have a conditional age here. I'm checking here if the next node is equal to research agents. If it's equal to research agents, we're going to move to the research agents. Else we're going to move here to the end node. And here we have here from the research agent to summarize agents, and from summarize agent to the end node. Then we're going to compile the graph, and after that we're going to invoke the graph. Now we're going to pass here an input like hello, and here as we pass here hello, we're going to interact only with the manage agents. Now let's run this and see what we're going to have here, guys. I'm going to run this. Okay, let's see here. Yeah, you can see in range node A. Now you can see actually we interact only with the manage agents. You can see pass here hello, and hello, how can I assist you today? Now, if I pass an input about real-time information, the manage agent is gonna move us immediately to the research agents. Now, if I pass you this, and I pass you what is the current weather, and pass you what is the current weather in New York. Now, let's see what we're gonna have here, and pass you this. Okay. Now, if I run this, let's see what we're gonna have here, guys. Now, let's see. You can see in ring node A. And node manager, in ring node research agents. Actually, the research agents is surfing the web in order to get data. And once we have the data, we are going to pass it to the summarize agents. Now, let's see. Yeah, you can see the summarize agents start working. In ring node summarize agents. Yeah, you can see actually they finish. You can see actually here we have the response. Now let's move at the top here, and then you can see here we have the human inputs. What is the current weather in New York? And then here you can see we have here the manager response. Okay, the latest weather information for you for New York. And then you can see we have here __ request __. Then please find the current weather conditions. We have a temperature, humidity, precipitation chance, wind speed, and a brief description. In New York City is now. Yeah, you can see the manager input. Now, if I move here, you can see now here, once we pass that input to the reset agents goes on the internet and grab data. And once we have the data, we are going to pass this immediately to the summarize agents, and then the summarize agents can summarize it. And the current weather in New York City for March 2026, you can see this, the response here, blah, blah, blah. And then the summarize agent give the response. Okay, you can see this how it works. Pretty easy. And guys, we just finished. This is how you can implement a multi-agent system using a handoff pattern. You can see pretty easy. Now, in order to improve your level, guys, it's better to check out this video. My name is A Clone. Go check out this video. It's going to help you to improve, guys. And don't forget to subscribe, and I see you in the next one. Peace.